In this video, which is part of the Cumbria Warmth from Wood project, we're going to be looking at an automatic wood chip system. This one is installed at Bassenfell Christian Centre near Keswick, and it's used to heat all the rooms within the house and the private accommodation there. These systems work by taking wood chip automatically, feeding it into a high efficient gasification boiler, and then the hot water is pumped to a thermal store, an accumulator, and then distributed to the house along a normal radiator system. Often the old oil or gas system is kept as a backup. So let's look at how the system works from the beginning. First, wood chip is delivered to the chip store, and this is most often done by a wagon or a tractor and trailer, and there has to be good access to the chip store to allow for good vehicle movements, easy vehicle movements, and you want to keep the chip delivery as easy as possible, really. The chip store itself has to be watertight to stop the fuel getting wet, and it has to be close to the boiler. The best design is usually a subterranean store, which is what we've got here. Chip then can be easily tipped into the store below, but this is not always possible, and there are options to blow the chip in or to use an auger to move it into the chip store. You might need a motor or hydraulics to lift the heavy lid, and the size of this chip store is dependent on demand, but it's best if you can design it to keep deliveries to about 4 per year. They do have a lot more deliveries here though. And so now we need to get the chip from the chip store into the boiler. This is fully automated. Inside the chip store is an agitator. These are spring-loaded arms which sweep across the floor to bring the chip to an auger. The auger then draws the chips to the boiler on demand. This is usually in 2 stages to stop the fuel potentially burning back to the store. This auger is where bridging and blocking can occur if chips are oversized. You would then have to dig this lot out to get the chip store clear. Not nice work. And so the fuel standards. The chips themselves have to be made by a wood chipper that does fuel grade chips. So you've got no large pieces, no big chunks which are going to block up the fuel delivery system. For most boilers, this has to be dry chip, usually less than 30% moisture content. Wet chip may start to compost in the chip store, which may cause a fire. Also, wet chip will burn very inefficiently. It will produce tars, which will damage the boiler and flue, and it will increase the smoke emissions. So you can use hardwood or softwood for your chip. You'll need a smaller volume of hardwood because it's denser. You can buy chip in, or if you've got your own timber, you can dry it and then hire a chipper to chip your own timber. But again, make sure it's a fuel grade chipper, and reckon on storing your chip no longer than about 3 months, as it might start to compost. And so to the boiler itself. This is a high efficiency gasification boiler, and it should run at about 90% efficiency. The chip is automatically fed into the boiler, and this is governed by this computer here. And it burns the wood at high temperatures, which generates gases which are then also burnt. This is where the efficiency is gained over conventional wood burning stoves. This heat is then transferred to heat exchangers in the boiler, and the hot water generated is pumped to this accumulator over here. This acts as a heat store. The hot water is then pumped to the radiators in the house, or wherever you want, on demand. And when the temperature in the accumulator drops, the boiler fires up and then drops into slumber again when the demand is met. And so if we look at the emissions from this machine, you can see the smoke is quite clear. You can just see a little bit of heat haze coming out. So we're not putting out loads of pollutants, and we're not wasting loads of heat through the flue. Burns much more efficiently than, say, a wood burning stove. And so to the maintenance. There's really not much to do with these. You just have to empty the ash out of this can about once a week or so, and then it's just normal boiler maintenance that you would expect your service engineer to do once a year. So one of the requirements of the renewable heat incentive is that you have an approved meter to measure the amount of energy that you've used. So this meter here records the kilowatt hours used by this system. And so for the cost of these chip systems, they are expensive. The smallest systems cost around £25,000. This system cost £150,000 to install. That's all the way through from digging out the fuel store, building the fuel store, concreting, tarmacking, connecting up the boiler and connecting to the existing plumbing work. So you've had this system now for almost 2 years. What's it been like to live with?
Well, it's great to know that it's more environmentally friendly than having oil, but it has, and it's great in terms of the heat that it produces in the manor. It certainly makes the manor a cosier place than with the previous oil boiler. And it has had much higher maintenance requirements from us as a staff team because of having to unblock it occasionally and sort out other problems.
So that's mostly down to the sort of quality of the chip, like some big lumps in it or something that's blocked?
Occasional big lumps, yeah. Initially one of the motors seemed as though it was a bit underpowered, and so that had to be changed. And we have had some oversized chip that causes blockages. And
what about the fuel supply chain? Has that worked well?
Yeah, we've got a long-term contract with Ferns, and so they deliver when we have a need for delivery.
Yeah. And then have you achieved the savings you wanted to with this system? Have you got the returns you wanted? We
initially hoped for about 40% saving on oil, but it looks as though it's nearer 25% to 30% saving. The efficiency of the boiler hasn't been as we'd hoped.
And that was really because the installers put in an oversized boiler, really?
We were told that the fact that it was larger than our requirements wouldn't really affect the efficiency, but it does seem that it is not as efficient as we'd hoped. So initially we were paying for the chip on meterage, and because the efficiency was lower than expected, we've had to change to paying for it by the meter cubed. Yeah, so instead of paying by the kilowatt hour, you're now paying by the meter cubed. Yeah. So all in all, it's sort of, there have been some wins and some knockbacks, but overall it's going to work in your favour, certainly in the long run, if oil prices continue to rise. Yeah, you have to see it as a long-term project, partly because the need to build the boiler house and wood chip store in the first place included a lot of concrete going into the foundations, etc., and partly because of the expense of the actual boiler itself. Yeah, so those high upfront capital costs and environmental costs. Yeah, it'll take several years to pay back.